Hello Internet. So we're back in the end here of our inverse mini unit, subunit, however you want to call it. And in this video, we're going to talk about how we can just get the equation of the inverse algebraically. Now we have kind of done this already, and there wasn't a video on this unfortunately, but we did this together in class. We talked about how you could find the equation of the inverse just using words. So here's what I mean by this. Let's pretend we have some function to start, and we'll say f of x. Sorry, pen's still skipping. F of x is equal to, say, 5x minus 3, all divided by 2. Okay, what we had done before is we kind of written out the steps, and I do like this because it's actually very fun for some reason, for me. Step 1, 2, 3, so on. Okay, well, how does this function work? And what I'm doing here is just writing out what this function machine does. Okay, so, well, step 0 is always you give it an input, so I guess I'll write that here. Step 0. Let's move this down, actually. Boop. Step 0 is you input x, whatever x is. Okay, and then what? Well, this function machine, if we're doing it correctly, it says to take that x, you go multiply by 5, then you subtract 3, and then you divide by 2. Right? You put that in there, then you go put that in there, and you put that in there, etc., etc., etc. Okay, we had talked about, well, if I'm undoing it, the inverse, the rule for the inverse, when we abbreviate that, f inverse of x. Well, again, step 1 is you give it some input. So we're still going to call x the input. We're still going to input x. Oops. And then step 1 here, well, we need to do the steps 1 in backwards order, but also do the opposite of them. So what I mean by that is the last step in the original function was to divide by 2. So the first thing to do when we're undoing our steps is to multiply by 2. So this will go times 2. Then what do we do? Excuse me. Well, then we add 3. And the last step would be to divide by 5. And so our function here, if we kind of work this backwards, how would this look algebraically? We would start off with x, multiply it by 2, so that's where we get 2x. We'll add 3, and then we'll divide that quantity by 5. And these would be inverse functions. You can confirm this, by the way, with the graph. They should, again, look like two lines. One will look like, well, I don't know exactly what these look like because I just made them up. One will look like this, and the other one will look like so. Again, mirrored across the line, or reflected across the line, y equals x. We mentioned that in the last video. So you can always check graphically that your equations are indeed inverses of each other. Now, unfortunately, this process does not always work. Well, that's probably not fair to say. I will say this though, this process is not always very easy. Because what if your function has x's in multiple places? You could just think of something like this, where your original function could be like x squared minus x over 3x, or something crazy like that. Things can get really weird, and we can see weird examples. So this doesn't always work, and it'd be easy if there was some kind of just formula / procedural way to do it. And there is. So to do that, let's take a look at an example again, and we're going to look at their tables actually. Alrighty, so we're going to look at, we're just going to use these two examples here. And so what I did, I just made a table here, and I just plugged in a couple x values to make sure to get integer outputs. Just makes our life a little bit easier. So we know then, based on this, we know that the table for the inverse function is just the original table flipped. And so in the original function, when I input -1, out came -4. So in the inverse function, when I plug in or feed it a -4, what should come out is, again, -1. Likewise, when I plug in 1, out came 1 before, so now feed it a 1, out comes a 1 again. So that one's not terribly interesting. But now, when I feed it a 3, out came a 6. In reverse mode, or the inverse mode, I feed it a 6, out comes a 3. And lastly, if before in went 5, out came 11, now when I give it an 11, out comes a 5. Notice, what did we do here? All we really did is we just changed the labels, right? What was X, right? This X column, oops, sorry, right here. The X column over here on this table is basically the same thing as the Y column right here. Not basically, it is exactly the same. And likewise, the original Y column or output column is the new X column. What does that mean then? Well, if on the table we just took X and Y and changed their labels, why don't we just try that with the equation? Sounds crazy, but let's try it. Let's see what happens. So the original function, and I'm going to go back to just using X's and Y's here because it makes our life a little bit easier. Well, our original equation, and let's move this down, is Y equals 5x minus 3 over 2. Sorry, let me clean that up. That's a little messy. Minus 3 divided by 2. Okay, so this would mean that the inverse, again, that's the original. This is the original. The inverse would mean, well, our equation would say Y equals 5y minus 3 all divided by 2. But usually we want to write something in terms of Y equals. We're just used to seeing it like that. So let's do that. Okay, hey, wait a minute. I'll multiply both sides by 2 to get 2x equals this. Right, so to get from here to here, we'll go times 2 on both sides, times 2. Let's see, next thing, we will add 3. And so we'll get 2x plus 3 equals 5y. And then we'll divide by 5, again, both sides. 2x plus 3 equals 5. Now check this out. You might remember that this is actually exactly what we did when we said, oh, let's use words to describe how to undo this original function. And so really what you're doing is you algebraically or symbolically or procedurally, if you want just kind of a formula to do this, to get the inverse of a function, all you need to do is take the original function, wherever you see an x, replace it with a y, wherever you see a y, replace it with an x. You end up with something like this. And then you just need to solve it for y. And this will be your inverse. And so if the original function, well, before this was f of x, so this would be f inverse of x. We'll cut it there for this video, but in the next 2 videos, I think we'll do 2 examples. One not so bad, and then one spicier example. Alrighty, so I'll see you there.